Okay, good. So we are still in for the set theory, and we are going to look at item 2 of the scenarios. So let's see what they gave us here, and we try to listen about it. So they're saying the sports officer was asked, the sports officer asked senior 4 students what game they play. It was found out that 20 play rugby. Now let's start summarizing straight away. 20 play rugby. Let's start summarizing straight away. Now we come and define to the examiner. That. Okay. Yeah, we are like a bit here that they're saying that 20 play rugby, but they've already defined it for us. It is R. So here there's no need. If they've defined it for you, there's no need of defining again. So 20 play rugby, that means that number in R is 20. Number in R is 20. Okay, good. 30 play soccer, that is S. Therefore, number in S is 30. All right, good. 15 play basketball, so number in B is 15, like that. Good. Now the thing, 6 play both rugby and soccer. So therefore, number in rugby, I told that the word and in simple terms means intersection. So here they're saying 6 play rugby and soccer. That means that R intersection S. So R intersection S is equal to 6. Great. Okay, now the thing, 4 play both soccer and basketball. So number in S intersection basketball, which is B, is 4. And 5 play rugby and basketball. So number in rugby intersection basketball is 5. Okay, is 5. Proceeding. Now we are in for a logic part here. Have a logic part here. The saying, the number. This is the logic part, please. This part I'm underlining here is the logic part. That part I've underlined is a logic part. Always pay attention to it. Why do we call it logic part? Because of this word twice. They can use the word thrice. They can use the word more by 5, more by 1, or less by 5. All those logic parts were handled when we were handling the 2 set diagrams. So please, you go and watch from lesson 1 up to lesson 4. Those lessons there contain all the logic parts and how we digest them. Good. So now the saying, the number of students who play soccer only is twice the number of students who play rugby only. Is okay? That's the logic part. Now the saying, the sports master wanted to know if the likelihood. Okay, we shall come to this. Let's first of all analyze the logic part. So the logic part. Allow me to write it here. Now the logic part, it is a special in a way that they're saying the number of students who play soccer only is twice. Now allow me to write like this. Allow me to write like this. Number in S only. Just allow me to write like that for simplicity. Number in S only. But of course, you know that number in S only is the same as this in the set language. Okay. If you have number in basketball, intersection rugby, intersection soccer, they want S only. It means that all these others are dead. Please, you can go and watch lesson 5. We define how this can be written. You can as well write like that, but even this kind of summary is okay. So number in S only. Number in S only. Number of students who play soccer only. So far, I just pick number in soccer only. The other statements mean nothing here. Soccer only is twice. So I will say is twice. I think that is twice. Number is twice. Number in rugby only. That is it. Please, I'm writing number in soccer only. I'm using this kind of writing for simplicity. However, the number in soccer only is written like this. You can go to lesson 5. Now, what happens here is they've said number in S only is twice the number in R only. Please, I'm only picking out sensitive parts. Soccer only is twice, dash, rugby only. Those are the sensitive parts you pick. Now, I told you, whenever you have this word twice, thrice, 3 times, then you have to let this last one to be any letter of your choice. You let this last one to be any letter of your choice. So you shall now say let number in rugby only equal to any letter of your choice. Any, okay, maybe x, like that. Then twice means times 2. So therefore, the number in S only, since they are being related, the number in S only will definitely be 2x, because twice means multiply by 2. Okay, good. We have analyzed our logic part. Now the same. The sportsmaster wanted to know if the likelihood of those who play. The sportsmaster wanted to know if the likelihood of those who play at least 2 games, if the likelihood of those who play at least 2 games exceeds 0.1. Now, whenever you see this word likelihood, then also if you see this word chance, likelihood, chance, those two statements, they mean probability. They mean that somewhere you'll have to get a probability. That's what they mean. Likelihood, chance, then, okay, likelihood of okay, the sportsmaster wanted to know if the likelihood of those who play at least 2 games exceeds 0.1. Okay, exceeds, wanted to know that exceeds 0.1, so what? Okay, so he can buy them more shoes. So maybe the sportsmaster wanted to know if those who play at least 2 games are more than 0.5. Now this is the probability. So for you, you go and get a probability of students playing at least 2 games. Then from there, you see if it exceeds 0.1. After the answer you have versus this, if it exceeds 0.1, then you say therefore the sportsmaster will buy them shoes. If it is less than this, then you say the sportsmaster should not buy for them shoes. That is what this means. Then another setting where they can bring, instead of bringing 0.1, they can say 10%. Like for example, exceeds 10%. Whenever you see a percentage, then you just know that is a probability at hand. All right, good. We can now proceed. Now we have all the information summarized. Tasks. Find out how many students play all the 3 games. Okay, good. Calculate the probability, but anything to do with calculating, we must have a Venn diagram at hand. Okay, so let's now draw our Venn diagram. Please, when drawing a Venn diagram, we strictly use a compass. Don't risk. All right, so let's do the Venn diagram very fast. All right, good. So I think you're also having a Venn diagram like that. So now let's put in the information. Let's put in the information. We have number in R equals to 20. So number in, okay, number in S equals to 30. Then also number in basketball equals to 15. That's what you're having. Then what else? So you put this, put that, put that. Number in ASR intersection S is 6. Now, before we do anything, we said, or we agreed that before you attempt or you start feeding in the information in the Venn diagram, you must have the value for this point. The one for or, the intersection, you must have the value for this point. Do we have it? No. If you look through all the data we have, we don't have the one for this point. And if you don't have it, then what do? You don't have it. Please, you always let it to be anything. So we can now say, okay, allow me say, all right, let number in S intersection B intersection R. Please, the order doesn't matter. You can start with S, you can start with B here. B, okay. Now, since you already have X in what we have read, here don't again let X, can let any other letter. I can call it what? I can call it Y. So let number in all the 3, OS intersection B intersection R, be Y. So now you come back here and put there your Y. Please, before you do a number of sets, you must have this guy already. Okay. Let's now proceed. We can now come to other information. Number in R intersection S is 6. Now, where is R intersection S? R intersection S is this region, by the way. It takes over, that 6 takes over this region, like this. I want to explain something here so some people can see. I think it takes on this shape here, whereby this is side of S, and this is, okay, and this is side of, okay, R. I've drawn only this part, please. I want to explain something on this part. So that 6 we have, the 6 takes over that whole space up to there. That whole space from here up to here. From here up to here, it is 6. But what if when they bring and that 6, they remove a y? What will happen? Here we remain with 6 minus y. So take note of that. So number in R intersection S is 6. So that 6 takes over this whole area. But part of the area has been taken with y. What will be the remainder? The remainder will be 6 minus y. You have to take note of that. Then they're saying number in S intersection B. Number in S intersection B is 4. Number in S intersection B is 4. S intersection B is 4. So that will be a 4 minus the intersection, which is y. Okay. Because even that 4 would take up this whole area here. So in order to get, but part of the area has been taken by y, so the remainder will be 4 minus y. Lastly, number in R intersection B is 5. So this will now be, in this part, you shall have a 5 minus y. A 5 minus y. Like that. All right, good. Now, let's proceed. What are they saying? Okay, yeah, we have finished to put in this, that. Now what is remaining? So we're saying that number in S only is twice the number in R only. Now this is the logic part. We have this and have that. Now number in R only, remember we agreed that in our summary, this is only. R only, S only, B only. So R only is here and is what? It is X. Right, good. Then S only is here and it is 2X. That came from the logic part. Now that's the information we have already. Then what are we going to do next? We want the value of X and the value of Y in order to be able to solve that question. All right, great. Now let's get, first of all, can I say, okay. Shall I say that now, do we have the number in the universal? We don't have the number in the universal. We don't have it. Please, they've not given us the number in the universal, and we shouldn't get worried. Please, even if they've not given a number in the universal, you can as well find the answers. And whenever they don't give you numbers in the universal, you come and use the facts for sets. Now let's see which sets are complete here. You see that this set here, we don't have this. So you shall not use it. So you're going to use this set and this set to find the values of X and Y whenever they have not given you the number in the universal set. So I think let's move on. Okay, so great. Now you realize that we are meant to proceed. And we need the value of X and Y. And how shall we get that done? Okay, and what you're going to do is, in simple terms, to get the value of X and Y, what you're going to do, we shall use the known circles. Number in R, it is all complete. This is all complete. So we use the fact that the number in R, that when you add the elements in R, the total you get is 20. So let's come and add. Our R is this. Our R is that. So now this will be, start with this. That will be X plus 6 minus Y. I'm adding what is in this circle, this, plus again Y, plus 5 minus Y. The final result you get is 20. We have added X plus 6 minus Y plus 5 minus Y. Now negative Y and positive Y, they can cancel out. So let's get the unknowns. We have X here. Another unknown is negative Y. Then let's add the numbers. 5 plus 6, that is 11. So plus 11 equals to 20. So therefore, the unknowns remain on this side. Then the 11 will go the other side. So that will be X minus Y is equal to 20 minus 11, like that. And that will now yield us or give us X minus Y equals to, I think that is a 9. So that will be equation number 1. Equation number 1. All right, so let us continue. Now, okay, why I'm using this set is because it's complete. Let me now come to this set. So now I'll come and say that the fact from number in S is equal to our 30, all right, and that was, okay, a 6 minus Y plus 2X, all right, plus Y, then plus a 4 minus Y is equal to 30. Okay, good. All right, now this positive Y and negative Y cancel out. What am I remaining with? I'm remaining with the 2X minus Y. Now add 6 plus 4. That will be a 10 and is equal to 30. All right. Now, what you're going to do, we shall now say that, okay, a 2X minus Y. Now, this 10 will go the other side. So 2X minus Y is equal to 30 minus 10. So it will now be 2x minus y is equal to 20. This is now equation number 2. And now in mathematics, what you must know is whenever you have two unknowns, then always expect a simultaneous equation. And now, as far as simultaneous equations are concerned, you all know how to solve them. You can use the elimination method, substitution method, matrix method, or graphical method. But in this kind of case, you can either use elimination or you can use matrix method. So let's now proceed. Let's continue. So you realize that here, you shall now solve 1 and 2 simultaneously. So I will say, just this statement, I will write it to guide you, but you shouldn't write it in the exams. Solve 1 and 2 simultaneously. Simultaneously. Solve 1 and 2 simultaneously. And please allow me to do it from here. Solving 1 and 2 simultaneously. Allow me to do it from here. And now this will be. I'll get this equation. So that will be. Okay, can I start with this? That will be now a 2x minus y is equal to 20. Then also I'll have my x minus y is equal to a 9. Now to eliminate them simultaneously, to eliminate the equations, to use the elimination method, you make sure that these ones here have the same values. And how do you make sure that they have the same values? You get a number here which is a 2, put it down. Then here, of course, just so there's a 1 there. Then the one which is here, you put it up. Simplest way of eliminating. However, now, okay, we can multiply. 1 times 2x will just be 2x. All right, good. 1 minus 2x times that. So my minus y is equal to 20. 2 times x will be 2x minus 2y is equal to 18. Now with this, how you make sure that, how can you make these ones become a 0? You can make them become a 0 by subtracting. And now 2x minus 2x is a 0. There is no need of writing a 0 there because the 0 remains a 0. Okay. Now here we have negative y minus 2y. Please be careful. It is negative y minus negative 2y. Be careful. Negative y minus this one. Negative 2y. This is how it is. But whenever a negative exists in between, you multiply them. So it will be negative y finally plus 2y plus 2y. Then what will you get? You end up getting just y. So therefore here we shall have y is equal to a 20 minus 18. That will be 2. So our value of y will be 2. Now you get this value of y and substitute it in any equation. So put y is equal to 2 in equation 1. In equation 1. But you can put in any equation, you end up getting the same answers. Me, I've chosen to put in equation 1 because it's simple for me. So what is our equation 1? What is our equation 1? What is our equation 1? It is x minus, okay, x minus y is equal to 9. But what is our y? Our y is 2. So x minus 2 is equal to 9. So therefore here, what will be the value of x? So x will now be equal to, now these 2 crosses the equal sign to come this side, to be now 9. Is a negative because the equal sign to become a plus 2. So that implies that our x is equal to 11, like we are. So when you're doing a certain number, please, the number can as well yield a simultaneous equation. This is mathematics, and they can as well set such scenarios in your exams. Okay, now we have the value of x, we have the value of y. Now we can come back and redraw our, Venn diagram. Okay, redrawing a Venn diagram. Let's redraw our Venn diagram. Please, you redraw also your Venn diagram. Redraw it very fast, and we see. So now this will be, okay, trying to redraw. Okay, that's my simple Venn diagram. Please, personally, I'm using a freehand, but for you, you shouldn't use a freehand. Use a compass. So this will be number in R is equal to 20, and the number in S is equal to 30. Then the number in B equals to 15. Now we have everything at hand. Now what is x? X is 11. Therefore here x is 11, so I'll put here 11. Here it is 6 minus y, but y is 2. So 6 minus 2, that will be 4. All right, good. Here is 2x. 2x, that is 2 times 11, that will be 22. Okay, good. Y is 2. Shall put there 2. Okay, 5 minus y. 5 minus 2, it will be a 3. Then 4 minus y, which is a 2, it will be a 2. Then you have, we don't have anything here. Okay, good. Now, how shall we get the value here? You all know that this is 15. The whole circle has 15. The whole circle has 15. But what will be the remainder here? Then what you do here, in simple terms, we add. So we know that I'll just use this side work, then I rub it away. So number in A, number in B is equal to 15. An implication that you can now put here, okay, you can put here another of your choice, maybe, okay, maybe A, like that. I'm using that A to get that value, the value for this point. That will now be A plus, the members which are in this set like this, A plus 3 plus 2 plus 2 equals to 15. So to be now A plus 3 plus 2 is 5 plus this is 7 equals to 15. So therefore A is equal to, the 7 comes this side, that will be 15 minus 7. And now our A will be what? 8. So now you have the right to come back and put there, you are mighty 8. Okay, good. Having reached there, now we can answer the questions that follow. Good. We are still continuing. We wind up with these 20 marks. Please, these are 20 scores. So just know it is worth it to at least give it enough time and watch the whole video to the end. So let's go and wind up very, very fast. All right, good. So let's continue. Now, what's happening here is we already have our complete Venn diagram. Let's go to the items or the tasks. Task part A, they said find out how many students play all the 3 games. So I'm answering part A. Find out how many students play all the 3 games. So now we'll say, okay, number all 3 games. All 3 games will be equal to, now all the 3 games is this one in the middle. And it is a what? It is a 2. Please, now what you must know is, in the new curriculum, whenever you're answering your questions, the tasks, you must always give your answer in a conclusive way. You bring a conclusive statement. Now, therefore, you can say, the number of students who play all the 3 games is 2. You create a statement of your choice, please. You shouldn't take my words, but you can also use your own statements to frame that answer in accordance to how you have understood that task. All right. There are no exact words to be used, by the way. You can frame, so long as you're using some words in the task, like they said, find how many students play all the 3 games. Now you can start. The number of students who play all the 3 games is 2. Or 2 students play all the 3 games. All versions can work. That's why I'm avoiding to write those statements there. Good. Now let's go to part B. Part B is here. They're saying, calculate the probability of students who play at least 2 games. Calculate the probability of students who play at least 2 games. Now, who play at least 2 games? Now, you can go and watch in the playlist. We have a video which shows how, that was lesson 5, how we go about the probability. Probability is always a fraction. And what probability also means chance. So I will say probability equals to number in the what they have asked for. Now what I've asked for in the question is this. You pick the set language in the question. They're saying calculate the probability of students and that at least 2 games. So that's what they've asked for. So you say number in at least 2 games. At least 2 games. That's how we find the probability over number in the universal. Oh, wait. Do we even have number in the universal? But it will be very easy to get. It will be very easy to get. Now, this number is a bit special. Not all set numbers that they must have a number outside here, the neither part. Not all of them. And not all set numbers should have the number in the universal. It's never the case. All right, now we continue. So here you realize that number in the universal, let's get the number in the universal by the way from here. So number in the universal is equal to, you add all values inside the circles. Don't add this. No, the one is inside the circles. So here we start to be 11 plus 4 plus 22. I'm moving like this, back there and finalizing. Plus 2 plus 2 plus 3 plus 8. Like that. So what will be our number in the universal? We are now getting it. Now this is it. 11 plus 14 plus 4, that is 15. 15 plus 22, that is a 37. A 37 plus 2, that is 39. 39 plus 2, that is 41. 41. 41 plus 3, that is 44. 44 plus 8, that is 52. So the number in the universal is 52. Okay, like we are. So you already have that. Now let's get number in at least 2 games. What do we say about at least 2 games? Please go and watch lesson 5 so that you get to know how we handle these at least cases. Okay, this will now be, now we say that for at least 2, we say that for at least 2 will be equal to, okay, at least 2 will be equal to only 2 plus all the 3. Only 2 plus all the 3 over number in the universal. Please, I'm only breaking it down for you so that you can understand. So now only 2 means what? We gave a summary. Also, you can go and watch lesson 5. We gave a summary that only 2 means this, that, and that. Only 2. Then all the 3 is this one. You can go and watch lesson 5 so that you can understand more about that. So that will be a 4 plus 2 plus 3. That's for only 2. Only 2 is this and this. Why only 2? Here we have 2. 1, 2, 1, 2. Or you can go watch lesson 5. Then finally, all the 3 is this one. These are the ones who play all the 3 games. So plus, again 2. But over number in the universal, which is a 52. So finally, what will be our answer? Our answer will be 4 plus 2, that is a 6. Plus 5, that is 11 over a 52. So it's 11 over 52. But remember, in our question, it is 11 over 52, but in our question, they gave us some probability there. They gave us some probability there, and they want a conclusive remark. Here, give your answer to two decimal places. A probability, give your answer always to 2 decimal places. Please use a calculator to divide that. So therefore, we have 11 divided by 52. Divided by 52. The answer we have is 0.21. That's in decimals, but you can leave it in fraction. Why I'm converting in decimals is to be able to convert the other side. Then also I told you, whenever you go in an exam and you find a question which has a percentage also means a probability. Like here you can multiply by 100 and then it will be 21%. So a percentage, a decimal, or a fraction in sets means a probability. All right, so let's go on. We are going to part C, where they're saying that advise the sports officer on whether to buy more shoes. Now, let's go and see which condition does this sports officer depend on in order to get these guys more shoes. Which condition is that? Which condition is that? Okay, great. And I know with that we can be able, or we can be in a position to refer. Now, using this point, they're saying the sports master wanted to know if the likelihood of those who play at least two games exceeds 0.1. Now, if they say likelihood means probability, at least 2 games is 0.1, means that you're going to find the probability of at least 2 games, then you will see. If it exceeds 0.1, then he has to buy for them shoes. If it is less than 0.5, he doesn't buy. Now let's go and see. But like we are in part B, we have already found the probability for. In part B, we have found the probability for at least 2 games, like we are. But if they had not asked for it, then you would go in to find it in order to come and complete up this area. Okay, good. Now, let's see. So let's see. Does it exceed 0.1? Yeah, the answer we have is 0.21. Those who play at least 2 games is 0.21. And 0.21 is greater than 0.1. So shall say, since 0.21 is greater than 0.1 or exceeds. Let's use the word exceeds. The very statement I've said. If since 0.1 exceeds, since 0.1 exceeds, since 0.1 exceeds, since 0.1 exceeds 0.1, comma, then you're giving an advice. Then the sports master officer, is officer. Sports officer should buy them more shoes. Should, don't say must. Should buy. Must is a commanding language. Should buy more shoes. Should buy more shoes. As simple as that. And those are 20 scores. Please don't forget to subscribe. Okay.